In this video, I would like to talk about LVM, which is Logical Volume Management. In our previous video, we talked about disk partitioning, which in the sense of the disk partition on our computer, when a file was getting full or when a storage was getting full, we needed to go and buy a new disk, which we're going to divide it as we need it, and we're going to take that side of the disk and decide to add on our on our computer. In a case if this extra disk that we added get full entirely, to add again, what we need to do, we need to unmount the disk that we have mounted here. We need to unmount it, create another partition into that on the new extra disk that will be created before attaching it again. While doing that process, we can lose some data along the way, which is not quite a proper ideal situation that we would like to have in this case. So to remediate to that situation, or maybe a better solution for that would be to create a logical volume that we need to attach into it. So what we will be doing in logical volume, we're still going to buy a disk that we need to partition still. On that partition, we're going to create a layer. This layer here that we create, we call physical volume. So we create a physical volume. On top of that physical volume, we will add another layer again that we're going to call volume group. On top of that volume group now, this is where we add logical volume. The advantage of this logical volume is that if this new disk that we created get full as well, dynamically mean we don't have to unmount, we don't have to remove everything. We can just add another extra disk, and on top of that extra disk, attach a volume group on top of that extra disk. And then from there, we can decide to extend the logical volume to go even beyond this new disk that we created. And the same again in the future, if this one gets full, we add another disk and we can still extend the logical volume. And this extension is done dynamically, meaning we don't have to unmount or remove the disk before we do the extend. We can do it directly. While on the disk partitioning, we would need to unmount the disk, partition it again before we decide to add it and mount it again all over, which is quite what make LVM a very big advantage in this situation, So the first thing first that we need to do before we get into LVM would be to partition the disk. We need to add the disk in our machine through VirtualBox, which we already did on the previous video. And here I need to check all the disks that I have attached on my computer, which we see here. We have a SDB and we have a SDC. So with LVM, we still go ahead and do the partitioning, which I will create a partition by doing fdisk into /dev SDB. Here I will do a N for new, and I will do a P to select the primary, and I will press enter to get the first partition, and enter for the first sector. And here, let's say the size of the disk that I want to create, I want it to be 1.1 gig. As I'm pressing enter, it's telling me that a partition here has been created, and we can do a P to print and see that we created a partition SDB1 of size 1.1 gig, which is a Linux. We would like to change that into LVM. So I would do type and capital L to see all the different type of typing that I have. Here, the 8.E is a LVM type. So I will press enter, and if I do P again, it's going to show that now it has switched from Linux to Linux LVM. And here I will do a W to write it. and path prop to notify my kernel of the change that I just made. So since I went ahead, I created a partition by doing lsblk, I can verify. Now this partition, I want to switch it into LVM. The first thing first, we need to create a physical volume. And before we start using all the LVM command, we need to install the package dnf-y install install LVM2. So this is the package that's going to give us the command that we need to use for manipulate our disk. So we need to do a pv create to create a partition, and we are doing that on dev sdb1. So a physical volume has been created. As you can see, you can do a pvs to verify, or you can do a pv display. So these two commands will show you that we have created a physical volume, and it's showing us the size of the physical volume that we have. So the next thing, we need to create a volume group. So for that, we do a vg create. That's supposed to be vg create, and on vg create, we need to mention now the name of the volume group. In this case, let's call it vg1, and we want to create that volume group on top of the disk that we just created, sdb1. So as I press enter, it says successfully created. We can do a VGS to verify, or we can also do a VG display to verify the volume group that we have created. And now that we have created the volume group, we need to go ahead now and create the logical volume. And let's say, for instance, as right now, I only want to use 10% of that disk to make it a logical volume. And for that, I need to do lv create and dash l. Here, I will say I want to use 10% of the volume group, right? And what is the name of that? And I want to give a name on my logical volume. Let's call it lv1. And that logical volume will be sitting on top of VG1 that we created. So, and as I do that, it's telling me that we have a logical volume that is created, and I can verify by doing a LVS. Here, it's telling us that we have a logical volume that is created. We can also do LV display. And the LV display here is telling us the amount of our volume group that we have as well, that we have created. If I do again a VG display, here it's even telling us here the total amount that we have of the size of the VG, and here down is showing us out of 100 and 1 gig that we have created. Now we are only using 2 gig for whatever what we need in this case. So after I created that volume group, we need to mount it, as we know that every time that you create a disk, you need to go ahead and try to mount it. Before mounting it, let's create a file system. So we do a makefs make file system.ext form, and here we're going to make a /dev. We decided to create that server that was vg1 l/lv1, which is this partition that we went in here and created. Since we have created a file system, we need to create a mount point where we're going to be attaching our disk. And let's say we're going to make it into make g on/mnt, and let's call our mount point 1 as well. So to mount it, we're going to go ahead and make it permanent. Will be by going in the file etc fs-style. Let's say I'm going to copy the mount point that, the gist that we have mounted. We'll go at the last line, or paste that, and then I need to mount it into mnt/1. It's a type ext4, and I'm going to set the default as permission, and here 0, 0. So if I do a gf-hg to see if a file is mounted, you don't see it yet as a right now, but by the time I will do mount-a, if I recall my command, now we're going to see that we have created a LVM partition here that we have mounted at the level of mnt1. So, and we can see that here the size of our partition is 104 or 103. So if in the future we decide that we would like to increase the size of our disk, for instance, now we're going to need to use our command lv extend. So lv extend, we do dash capital L. Let's say we decide to increase maybe 200 meg for our for any purpose that we would like, and I will do the -r, meaning extend the file system automatically as we are doing that mount. And the mount here is going to be, that file is mounted on dev vg1 lv1. As I'm pressing enter, it's telling us that here the file system has been extended automatically, and we can do gf-hg to see what is going to be the size of our new LVM, which went from 103 to 207 automatically. And in the same manner, we can decide to reduce the file system for any purpose that we will need in the future by using a lv reduce command. And we still do dash capital L, and you can do -15 meg if you decide to remove about 50 meg, -r to resize it, and here we're going to do /dev on the vg1 lv1, and I will say yes, and as I press yes when I change it automatically. And if I do gf-h capital T, we see that the value of LV have changed in this situation as well, which is what make a big advantage on using LVM to manage and manipulate our disk depending of what result we need. So we can go ahead and see a couple of advantages or different characteristics between using this partitioning or using the LVM logical volume management, which the reason why we might want to use one situation depending of whatever type of result we are looking to have. So go ahead, practice it, and get yourself more familiar with the LVM tool and managing your disk.